January 1945. The Ardennes forest still breathes smoke and frozen mist. Snow lies packed into the churned earth, pressed flat by retreating boots and shattered armor. Artillery echoes like distant thunder, rolling through pine trunks and across river valleys. Along a narrow, half-frozen stream, men in olive drab crouch low, steel helmets rimmed with ice, hands numbed as they lift steel panels into place while shells fall close enough to shake the water itself. This is the moment German engineers never expected to witness. By the winter of 1944–45, Germany's military engineers believed they understood the limits of Allied logistics. Rivers were natural barriers. Destroyed bridges were delays that bought time. Under fire, construction stopped. That belief had been reinforced across Europe, where blown spans over the Meuse, the Moselle, and the Rhine had slowed advances again and again. In German doctrine, bridging was deliberate, slow, and vulnerable. A river crossing meant preparation, silence, and often air superiority. But the Americans brought something different. The Bailey Bridge, a prefabricated steel truss system designed in Britain but adopted and mass-produced by the United States, was not just a piece of engineering, it was a doctrine made of steel. Standardized panels, interchangeable parts, and simple pin connections meant that bridges could be assembled by hand, without cranes, often in hours rather than days. American factories produced tens of thousands of components, shipping them across the Atlantic in endless convoys. German intelligence knew of the Bailey Bridge. What they did not expect was how it would be used. German engineers expected rivers to pause the enemy. They expected shell fire to halt construction. They expected chaos under pressure. Instead, they saw calm repetition, panel by panel, pin by pin, steel ribs sliding forward across water while machine gun fire croaked overhead. To them, it was not bravery alone that was shocking, but method. Reports from German engineering units in late 1944 repeatedly note the astonishing speed of American bridging operations. One after-auction assessment described U.S. forces erecting usable crossings within the same day, sometimes within hours, even while artillery harassment continued. Another noted that destruction of a bridge no longer guaranteed delay, a sentence that quietly admitted a strategic failure. What German engineers expected was scarcity. What they encountered was abundance. Each Bailey Bridge seemed to appear from nowhere, its parts already waiting, stacked in neat order. Trucks arrived on frozen roads with more panels than were needed, more rollers, more decking, more tools. If a section was damaged, another replaced it. If a bridge was shelled, a new span rose downstream by nightfall. The recurring sound was not panic or shouting, but the metallic clink of steel pins driven home, again and again, steady as a clock. The sound of those pins became a symbol. Historically, the Bailey Bridge was a triumph of industrial thinking. Designed by Sir Donald Bailey in 1940, it required no heavy machinery and could be launched from one bank by manpower alone. The United States refined its use at scale. By 1944, American engineers had standardized bridging drills so completely that units could assemble hundreds of feet of bridge under combat conditions. At Remagen, at the Rohr River, at dozens of lesser-known crossings, Bailey bridges followed advancing troops like shadows made of steel. German engineers recorded their frustration in technical language, but the meaning was emotional. Rivers had always been allies of defense. Now they were liabilities. Demolition charges became temporary inconveniences. Natural obstacles lost their power. In one captured report, a German officer noted that American bridging capacity appears inexhaustible, a word rarely used lightly in wartime assessments. The transformation was ideological as much as tactical. For German engineers trained in a system strained by shortages, improvisation, and late-war desperation, the Bailey Bridge represented something unsettling. It showed that American strength was not just courage or firepower, but organization, democracy expressed through logistics. Factories back home producing identical steel parts in quantities so vast that loss did not matter. If one bridge fell, another would rise, because the system behind it could absorb failure. The symbolic object remained the same: steel panels stacked beside a river. Each panel weighed roughly 570 pounds, manageable by small teams. Each pin fit any hole. Nothing was unique. Nothing was precious. This lack of uniqueness was the power. German engineers, accustomed to specialized equipment and dwindling resources, faced an enemy whose tools were designed to be replaceable, even expendable. It was a different relationship to material, and by extension, to war. American records confirm the scale. By the end of the war, Allied forces had constructed over 2,500 Bailey bridges across Europe, some spanning more than 700 feet. They carried tanks, trucks, artillery, and entire armies. Many were built under fire, repaired under fire, and expanded while battles still raged nearby. Training manuals emphasized speed over perfection, function over form. For German engineers watching from the far bank, this was not merely engineering. It was psychological. The river no longer promised safety. Destruction no longer guaranteed delay. The old calculus of defense failed. In its place stood a cold realization. The enemy's strength was systemic. It could not be bombed out or exhausted quickly. It flowed, like the rivers themselves, around obstacles and through resistance. As the war ended, many German engineers reflected not on weapons but on processes. Post-war technical interviews reveal a recurring theme: admiration mixed with resignation. The Bailey Bridge became shorthand for American capability, a visible reminder that industrial democracy could mobilize not just men, but ideas, designs, and production at a scale that overwhelmed traditional military thinking. In the quiet after the guns fell silent, some of those bridges remained. Steel trusses rusting gently over European rivers, carrying civilian traffic, blending into landscapes once torn apart by war. The sound of pins driven home faded, replaced by footsteps and engines, but the lesson endured. A bridge built under fire is more than a crossing. It is a statement. It says that obstacles will be met with preparation, that destruction will be answered with rebuilding, and that abundance, when organized, becomes resilience. For German engineers who never expected steel to rise so quickly from frozen rivers, the Bailey Bridge was not just an engineering surprise. It was a revelation about the kind of world that could outbuild war itself. And in that revelation lay a larger truth. Freedom, when supported by industry and shared purpose, does not merely advance, it connects.